Learning online is less personal. I know. A lot of what I do is based on. Make it fun. I think the key is getting kids to understand what you're talking about and what it means. That way they're not just memorizing some random form. Y or M equals Y2 minus Y1 over X. We've got this, right? How? What is split? Rise over run, right? How much it goes up and how much it goes over. Which variable deals with up? X or Y? I asked the question. Variable deals with up, X or Y?
Y.
Well, I asked the question. And then X is the run, obviously, right? It's left to right. So of course it's the Y stuff over the X stuff, it's M, right? Something like that, right? Now why are we subtracting them? Talking about distance, right? How far is 6 away from 7? Well, 1. How do you figure that out? You subtract them, right? So it's the distance vertically over the distance horizontally. How far you're going up, how far you're going over. Rise over run, right? Now why do they have Y2 and Y1? Because technically these can be different values, right? Remember how earlier we talked about how X minus 12 equals X minus or plus 30 had to have different values for X and true, right? But normally we don't use the same variable to mean different values. That's kind of silly. Why do they use the same variable here when they mean different values? Why do they do that? But Y tells you it's vertical, right? They're both vertical values, but they're different vertical values, right? So that's helpful to know that they're Y values because it tells you they're vertical. And the numbers down here just say, hey, look, it's 2 different values. Same thing here, they're both horizontal values. So it's the rise over the run. That's all it is. You don't have to memorize this. And then it'll be like later, they're like, oh, and there's also point slope form. This, oh my God. I've memorized that one too. You notice anything similar here? This whole thing, once you get your answer, is the horizontal distance, right? It's some number, right? You do like 7 minus 6 and you get 1, right? It's going to represent a number. So let's treat it like it's a number. So instead of dividing by a number, what can we do? Multiply by a number. What happens when you multiply? Oh, wow. It's this. Behold, a whole different form. Good luck memorizing it. And some of you will remember this one and forget that one. Right? Obviously, you don't understand what's happened. Right? If you knew what it meant, you never forget either, or you never forget both of them, or well, one and not the other. Okay? But yeah, I don't have this memorized. Proof of that, I actually flipped them earlier because I wasn't thinking. Right? And then Katie made a really good comment because last year she learned, I think, maybe take a little bit of credit. And it has to be rise over run, right? That's what it is. How could X be on top? That'd be run over rise. That's what I'm talking about. Yo, Parker Porin. Welcome to the show. All right, so that's algebra. Today we're talking about subtraction, which I already revealed on accident. Sorry. It's distant. Someone banned this man. Alrighty, let's do Tendy, and then we'll get going. In the meantime, portfolio conferences yesterday. If you did them, what'd you think about it? What'd you think? You thought it was going to be bad initially. Let's break that sentence apart into the two interesting tidbits, I think. One, he thought it was going to be bad, and two, it wasn't. Let's talk about why you thought it was going to be bad.
I don't know. I thought it was harder.
Okay. I think online learning is always inferior to in-person learning, just because imagine you're in person and you want to do something online. Okay, we can do it. Imagine you're online and you want to do something in person. Well, you can't, right? So automatically it's going to be better to be in person because you can do whatever you want in person, right? But I don't think there has to be a significant difference between the two. I think there is because we're just not prepared. We're not used to doing it. It's a new thing. We just now got cameras for all the teachers. And that doesn't matter because they can't screen share and use the camera at the same time. Right? So, yeah, you know, but does it have to be this bad? Oh, God, no, right? But it's very convenient that it is this bad because when they start saying, let's get everybody to go back to school and, you know, take off their mask and just go back to normal because we need attendance numbers for funding. It's very convenient to be like, well, it makes sense we have to do this because, look, remote learning is so bad. It's bad for their education. It's not good for them. And people go, oh, yeah, no, that's right. It really did suck. The self-fulfilling prophecy. It doesn't have to be this bad. Joe's here, Carly's here, Connor's here, Ashton's here, Blaze is here, Jocelyn is here. Chase, are you at home? Parker, I see you, thank God. Massandra, are you here? Brennan is here. Paul, Grant, Geraldine. That's why Grant's not here today to open the door first. It's not his day. He's a B-Day kid. All right. Let me know if you're here, and we'll mark you here. People are gone. So Ashton thought it was going to be bad, but it wasn't that bad. Anybody else have an opinion on how things went yesterday for the portfolio conferences? Some of you didn't do them. You showed up at one point, and then I didn't see you later. That's okay. I don't mean to shame you. I just want to make sure, like, tell you, like, hey, we'll figure this out. But we gotta meet. Same thing with you. Blaze, we met. Jocelyn, did we meet yesterday? I don't think we met yesterday, right? Okay, so we need to meet and get that figured out because that is your grade. Connor, did we meet yesterday? We did not. So I only had 3 show up. I had you sign up. I had you sign up, but you didn't show up. Was the sign up confusing? Was it difficult? Was it hard?
I was confused for my cousin first.
Were you the weird one that like someone signed up double somehow?
Yeah.
You were. Like someone else signed up for your time as well?
Yeah. Someone signed up for
I don't know how that
11:20 and then someone else signed up for 11:25.
I remember the 20.
And we're like, what's going on?
Yeah. It worked out because the other person didn't show.
Yeah, because it was Theron, but then you.
Right, yeah, Theron, yeah. We it was fine. I'd already left him a ton of comments. It worked out. Yeah, I don't know how that happened, but I don't know if you signed up like simultaneously and the computer didn't know what to do or what, but wild. Because there wasn't a slot that was separate for, you know, 2 at the same times. How could it be better? Give me feedback. What do you think? Any ideas? For those of you that did it, did you feel like you had enough time to get through it and have a good conversation about it? Do you feel like it was beneficial? Was it? Okay. Wasn't a waste of your time? Okay. My thought from yesterday was I don't think 5 minutes is enough. I think 10 minutes is probably safer. And if we go under, that's fine. But I think most of our conversations were longer than 5 minutes. And it left very little time for you to be able to talk with me. Response, because I was rushing to get to the next person. So I think what I'm going to do, since there literally is not enough time in the day for everybody to have 10 minutes, all 69 of my students, I think I'm going to split it between 8 AB days, and we'll do every other week for conferences. If you want to meet with me every week, just to like check in or whatever, totally fine. Totally fine. But I think I'm going to make it mandatory every 2 weeks that we have to have a conference. And that'll be when you get your grade. Does that make sense? Does that sound okay? Is that okay? Right. For those of you that did not meet with me yesterday, we need to figure out a time to do that eventually. Okay? People online, why am I only seeing Parker today? Am I missing everybody else? Let me check my email, make sure I'm not getting a ton of emails from kids that say they can't comment. I think Parker probably dipped. Prove me wrong, Parker. Prove me wrong. Yeah, we got to get that figured out and soon. Grades will go in this weekend once I've cut up all the recordings and then made them their own separate like things. And then I'll post those links in Skyward for your parents to view. I had to make phone calls this weekend for kids that didn't show. So don't make me have to do that. Cut down on my phone calls. Meet with me soon, okay? Send me an email. We'll figure out a time to do so. But obviously we don't have a ton of time. Fit that in. Trying to upload an image to my drive so I can put it on Bulb. Oh wow, look at this guy. Look at this guy. Donde está everyone else? Okay. For today, we're going to talk about subtraction. We already kind of, found out that subtraction, I knew it, my keyboard was slid up, that's why. That subtraction is distance, right? Because Jerica and Katie made me spoil it. So number line, everybody loves them. So if we have two numbers, like, I don't know, give me a number, go. Awesome, give me another number, Blaze. Okay, so 8 is bigger, so I'm gonna put it over here. 2 is smaller, so I'm gonna put it on the left. Taco Bell. Okay, so the distance between 2 and 8 is just whatever 8 minus 2 is. Right? Now what if we go the other way? Because this is in this direction, right? Going from 2 to 8, the distance is 6. What if we go the other way? This way. Well, the distance is going to be negative 6. Can you have a negative distance? Well, it depends. You tell me, you're the mathematician, right? Do you want to have direction implied when you talk about distance? Maybe you do, right? You know, talking to your grandparents, are like, yeah, we walked to school back in my day in the snow, up the hill both ways, right? So direction matters, I guess, right? But, maybe it doesn't matter to you. Oftentimes when we're talking about distance, we want absolute distance, right? We don't want direction necessarily. We want that out of the equation. So what we do is this thing called absolute value. You know about that? You ever learn about absolute value? The two little lines, and everything inside it means it has to be positive when all is said and done. So what we're doing here is 8 minus 2 absolute value, also known as 2 minus 8 absolute value. These are the same, right? The distance between 8 and 2 in absolute terms, not talking about distance, is the same, right? In other words, they teach you, well, this is going to be negative 6, but then you make it positive. Yay, they're equal, right? Okay. The idea is that we use absolute distance, right? No direction. But anyway, back to just regular old subtraction. In general terms, not speaking specifically, and when I say general, I mean like working for any numbers, right? Is this general? No, because I use 8 and 2, right? That's a specific case. Do you see the difference? Specific cases, specific numbers. In general terms, which is always what we want to do for math, because it could be a coincidence, right? Like 2 times 2 is the same as 2 plus 2. Does that mean 3 times 3 will be the same as 3 plus 3? No, it's a coincidence that 2 times 2 and 2 plus 2 is the same, right? So in order to avoid coincidences in math, what we do is we don't use numbers, we use general terms. And those general terms are usually variables. So we use A and B, and we say the distance between them is always going to be A minus B. Something like that. Or I suppose if we do it this way, the better way to do it would probably B minus A, because that guarantees it's positive. Why does B minus A guarantee it's positive? Yeah. How do you know? Exactly. Right. So we can say something like this without a number line. If A is greater than B, then I switch colors, sorry. Then B minus A is the distance, right? Something like that. If you flip it around, if we put A before B, then we're going to get a negative number. That's okay most of the time, as long as you know that you're getting a negative number. Okay. Why could getting a negative distance be a problem? Well, think about it. If I'm traveling from point A to point B and then to point C, I want to add their distances together to figure out how long I got to go, right? But if I get a negative distance for this and a positive distance for that, when I add them together, I'm not going to get the total distance, am I? Right? It's going to take away from that. It's going to screw up my calculations. So that's almost always why we do distance in positive terms. Cool. Let's talk about subtraction and how else to think about it, right? We can think about it in terms of distance. So if I ask you a question like 21 minus 7, how would you do this problem? There's lots of different ways to do it. How would you do it? Yeah, go ahead, Afton.
7 minus 1 is 6. Good.
7 minus 1 is 6. Okay. So what you're doing is doing like the opposite. You're like doing this.
Basically, but I got rid of 76.
So you're like, I'm going to think about it like this. And now I've got 6 minus 20. And then I've got negative 14. But I know I flipped it around, so it's really positive 14. Whoa, that's wild. That's wild. So he's like, I'm always going to flip it around to make it more comfortable for whatever I am and know that if I flipped it, I need to change the sign at the end. Interesting. And why does the sign change if we flip it? Because this is asking, if I start on 21, am I doing the right way? This is my hand up right now is your right or your left? Your right. I have it mirrored, don't I? I think I have it mirrored. So it's your right. Okay, so the farther distance. Okay, so here's 21, here's 7, right? The distance from 7 to 21 is going to be positive. The distance from 21 to 7 will be negative because we're going backwards, right? So we're asking here the distance between 7 and 21. That's kind of strange, right? 21 comes first. We're asking, if I start on 7 and I go to 21, what's the distance? 14, right? That's just kind of goofy like that. You kind of have to read it backwards if you're thinking in terms of distance. This is asking, if I start on 21 and go to 7, what's the distance? Well, it's negative 14. So when we flip them, it just changes the direction we're going, which means we change the sign for our answer. Yeah.
There's not a, I did it like, I think like, just try to film.
I think I know what you mean. Let's talk about that a little bit slower so I can, okay, so what's going on here?
Try to think, but
What plus 7 would get you? Ooh. So basically, our boy's thinking this, right? And then he's like, look, the real question we're asking here is this. What plus 7 gets me 21? So he's like counting up from 7. In other words, he's thinking of a number line, and he's counting up how many he needs to get to 21. That's going to be the distance, right? We're counting the distance, essentially. Damn, son, nice job. Right, and that's where algebra comes from. That's why subtraction and addition are the same thing. One's asking how far are they apart, and the other's saying if I start on 7, how far do I have to go to get to 21? Right? That's what it's saying. Sure, right? And again, if you're doing PEMDAS, if you're following procedure, well, you'd add 7 to both sides. You do that. You go cancel it and get other. You get that. So there's equation. I think that's right. I hope I didn't make any mistakes. Instead of just being like, well, yeah, the distance between 21 and 7 is the same thing as asking, how far do I have to go to get from 7 to 21? Right? Words hard, math easy, but in this case, words are kind of helpful. And it's because they're related. Nice, so you're counting up. We have the other method of, look, I'll flip it whichever way I want, and just remember that I need to change sign at the end. Because if I flip it, it changes direction, right? And direction is all that plus and minus are, right? That's it. When we talk about negative numbers, that's all they are. They're just to the left of 0. That's it, man. How else would you solve a problem like Maria? Yeah.
Why do you call all the problems?
This is not a quick answer. Y'all ever seen Sound of Music? Maria is a nun that doesn't fit in very well. No, I don't. I want the good one, not the. Swear to God. No. This is important for context because the rest of the year I'll be doing this. Hey, I'm live. Maybe we should watch.
You're my favorite granddaughter. Well, I can say that because there's no one else listening.
She climbs a tree and scrapes her knee. Her dress has got a tear.
This movie's about Nazis. You don't realize that until the end. It's a true story, too.
And underneath her whimper, she has curls in her hair.
Not acceptable.
She's always late for chapel and her penitence is real. She's
Try to figure out.
always late for everything except for every meal. I hate to had to say it, but I very firmly feel Maria's not an asset to the Abbey. I'd like to say a word in her behalf.
Say, Sister Margareta.
Maria makes me laugh. How do you solve a problem like Maria? How do you catch a cloud and pin it down?
How do you catch a cloud and pin it down?
Go up with a club.
You can't, exactly, that's the point. You can't, because it's a cloud. You can't solve a problem like Maria, because she's Maria. You don't do that to Maria.
Grab a cup and break some of it
How do
down.
you find a word that means Maria? A flimsy gentleman will miss a clown. Many a thing you know you'd like to tell her. Many a thing she ought to understand. But how do you make her stay and listen to all you say? How do you keep...
How do you make her stay and listen to what you say? It sounds like what we're trying to do with you guys, right? You can't. Online learning and in class, even when it's in person, you cannot make them stay and listen to what you say. And every time we have a conference where it's like, how to motivate your students, it's a load of baloney. You cannot motivate people. It has to be intrinsic. And every time you hold that carrot or give that stick to get them to do something, it kills their internal soul a little bit more. That's why you guys are addicted to your phones, because you need that carrot and keep going back with that dopamine rush. You can't do anything else, because as soon as you're pulled away from that, not to blame you guys, it's me too, right? It's everybody in society, right? As soon as you pull that carrot away, it's like, I don't feel like doing anything. I feel like crap. I feel depressed. And it's true. You do. And it's not your fault. It's that you're so used to having that dopamine running in your system. As soon as it's gone, you feel like absolute shit. And so when we're not hitting you with a stick harder and harder and harder, or not giving you a bigger and bigger carrot, eventually you just are like, well, I already have 12 carrots. Why do I need a 13th? I don't want to do this work. Or yeah, you're going to hit me either way, right? Eventually I'm going to get smacked with the stick when I get tired of doing this. And then we go on online learning, we're like, oh my God, the kids don't want to stay and show up and do attendance and pay attention in class and everything's failing. Dude, it was already failing. The only reason you didn't think it was because eyes were on me, and that's how I know you're learning. You ever hear that, the teacher? Baloney. All you know is they're being compliant. I read Olivia Barron's post the other day. It was brilliant. Brilliant line. I love this class because we're allowed to do what we need to do. I can be on my phone, I can sleep, I can do whatever I want. And a teacher reading that would go, oh my God, who is this guy? What is he doing? And then she says, in other classes, I'm not allowed to do that. In other classes, I have to have my eyes on the teacher. But when I get to do what I want, I get it out of the way. I sleep, I wake up, I get my homework done. Now I can pay attention if I want to. Whereas before, it's always in the back of my mind bothering me, and I can't. But my eyes are on the teacher. And even though I'm not really paying attention, it looks like I am. And I get the grade, and the teacher thinks I'm paying attention, and no learning happens. How do you keep a wave upon the sand? You can't.
Keep a wave upon the sand. Oh, how do you solve the problem like Maria? How do you hold on in your heart?
I love that line because the moonbeam comes from the moon. The moon is we all have access to it, right? And the idea of holding the moonbeam in your hand is an idea of ownership. You're missing the whole goddamn point. That's not what makes the moon beautiful, is that you own it, you can show it, right? It's that everybody has access to it. It's this thing we all understand. That line of I'm looking up at the moon and maybe the person that I care about is also looking at the same moon, wherever they are. As soon as you try to hold it in your hand, you kill it. That's what we're trying to do to you guys, and it pisses me off. All right, so how do you solve a problem like Maria? Now this one hopefully is solvable, but I assume most problems aren't until proven otherwise. It's pretty arrogant to think that every problem is solvable. It also speaks to our schooling, that every problem we give you is solvable. And you should be able to do it, and if you can't, it's because you're defective. I'm done now. How do you solve a problem like Maria? How would you do it? I love my job. Any other ideas? Yeah, go ahead. Feel free.
You can think 7 things 1, and then get rid of 7, and 7 times 2 equals 14.
One less group of 7, right? So really what we have here is 7 times 2. Very good, very good. Another way to think of that exact same thing is to write it like this. Yeah? Right? Do you see how they're both talking about in terms of 7s? Right? We're talking apples to apples here. We're both talking about 7s. So all we have to worry about is not the thing that's in common, but the difference. Right? And we know that the difference is 2. So it's just 2 groups of 7. 3 groups of 7 minus 1 group of 7 is 2 groups of 7. That's 14. Oh, yeah. Oh, yeah. I used to have a bio teacher that would do that when you say something smart.
Why did you say plenty?
I don't know. How would you do it? Come on. Somebody knows. Somebody knows. Let's go. Okay, go ahead.
You push actually.
Woo! Exciting.
Then you change it out with a 1.
Ooh, okay.
And then put a 1 in front of the 1. The 1 on the right.
That's what we're doing right
and
now.
then it's 11 minus 7.
Oh, gotcha. And how would you do that?
7.
Yeah.
Get rid of the 1 again.
I'm listening. I'm just curious.
I get rid of the 1 again. 10 minus 6. So just, I think.
Whoa, 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 whoa. Hold on a second. Hold on. You're telling me 11 minus 7 is the same thing as 10 minus 6? What? What? You don't talk. Anybody else? What do you think about this? Joe's shaking his head. Blaze.
There's like,
You're moving them together. Guys, check it out. I'm not going to draw a number line, okay? Imagine 2 points on a number line. This is their distance, yeah? Now, what if I add 1 to both numbers?
stay the same.
What if I subtract 5 from both numbers?
Stay the same.
The distance, subtraction is distance. The distance doesn't change. Holy, right? 10 minus 6, any day, bruh. Any day. 11 minus 7, oh my God. Sorry, I can't give you change. The power's out. Oh my God. 11 minus 7 is the same thing as 10 minus 6. I think most of us do, right? So it's 4. Whoa, we're gonna come back to that. Nice observation. And then we have 1 minus 0, which is 1. We get 14, right? Why? What is happening here in red? What is this? Why? How does that make sense? Why is that a thing? I know it works because I got the right answer. My teacher told me it worked. What?
Take away one of the, moving it over into one's place, which makes it 10.
21 is the same thing as 10 plus 11. That's what we're doing. Right? So it's just 11 minus 7, which is 4, plus 10, 14. And I know 11 minus 7 is 4 because lots of reasons, but one of the reasons is, well, it's the same thing as 10 minus 6. Three plus 1 is 4. Ooh. Okay. 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 What about this? Watch this. What's 1 minus 7? Yeah, what's the distance between 1 and 7, right? But we're going from 7 to 1, right? It's minus 6. Okay, what's 2 minus nothing? 2, and that's not a 2, that's a what? Try again. 20, it's a 20. It's okay, you were answering the wrong question, but you answered it correctly, right? It just wasn't what I was thinking. Who cares what I think? 20 is what we get, minus 0, which is 20. What's 20 minus 6? Oh, we don't have to borrow. Okay. Okay. Do you notice anything about 21 minus 7 and 20 minus 6?
Minus.
20 21 minus 7, ew, but 20 minus 6, oh, okay. What? Are you kidding me? How long have you been doing subtraction? How long have we had to tell you any of this? Your whole lives. And we're just like, no, you have to borrow. And if you get a big number in your head, you just gotta borrow a lot. You just gotta, that's how you do it. It's the only way we know. What is subtraction? I don't know, you take away. Then we introduce negative numbers and we're shocked that you guys have to spend 3 years trying to figure them out and you still don't really understand them, right? Because you never understood subtraction. Who is doing this? I don't even have a math degree. I'm like 1 credit short. I need to retake calculus. I told you this, right? I clept it. I took the exam. I taught AP calculus the year before without a math degree. And then I took the exam and they passed me. And then the state's like, wait a minute. It says you have to take the class. We interpret that as taking it in person. Law didn't change. They just reinterpreted it. Fast forward 4 years later, everybody's taking their classes online. So guess what your boy's doing right now, right? Taking the class again online in order to satisfy the, well, you had to take it in person. Who cares what it means? About compliance. Okay. Cool. All right. I'm smiling. You just can't tell. Joker style. Joker, but 2020. He didn't like cut his things. He just like, threw it on his mask and. Okay, I'm done. How would you do this? What's your preferred method? Okay. That's valid. How would you prove that the answer is correct, that your calculator is right or whatever? How would you convince a new student? Calculator would be a really crappy way, right? Which is hilarious because that's the way we have you do math, right? We learned a new thing today. Here's how to do it on a calculator. Now I understand. Calculator's fine for getting the answer, and that's important sometimes, right? Like, cut to the chase, bud, right? But like, when you're first learning a new thing, that's a terrible idea. What a waste of time. Yeah. Like how? What did you do in your head first? Can you walk us through the steps? I know that's kind of hard to do.
I thought of 7. I tried that.
Counting out. The Blaze method. So 76 to 100. Well, it has to be less than 30, right? 70 to 100 is 30, so it's less than 30, it's like 24, right? And then how do we get to 45? Well, 45, right? After we're at 100. I don't have one for that. Nice. Nice. Give me another one. Nice job. Wait, hold on. NBA Jam, baby. That one's loud. I used to have the inception button before I had any of this stuff and I taught calculus. Because calculus is all about like getting deeper and deeper into the problem. Like a whole nother dream. You've seen the movie, right? Right? And all of a sudden someone would be like, wait a minute, does that mean? And then I hit bull. Bull. And the entire room would shake and people next door would bang on the wall, the teacher. Hi, Miss Crimmins. Shout out to you. I hope you're dead. Just kidding. I hope you have excellent health care. See you later. I want you to think about subtraction and different ways to do it. How would you tackle this problem? Write about it. Go home and do that. Or in your next class when you're not doing anything. Write about it. Love you all. Bye, Joe. Glad I can make you smile.
So tomorrow, what do I gotta do?
For what? Watch the video at some point. I don't care. You do you. Okay, we're gonna talk about division, I hope. Actually, we'll probably talk about negative numbers.
Okay.
Oh, we got a treat for you today. Oh, I love your hair. Oh my god. I'm not talking about you guys. Y'all turn around. Haha. What? That's for what? I love your shirt, by the way. It's Fox for life, baby.
I forgot.
Kobe.
Exactly. I forgot about it.
You can do whatever you want, Nika. You can do whatever you want. Is that? I hope you.
I didn't know what we were doing today.
It's sincere. Oh, we're learning.
First of all.
I hate when that happens. Sorry. I'll ask from now on. Guys, is it okay if I... You can do what you want, seriously. If you want to study, go ahead. Okay? I bet I'll distract you. If I can't distract you from studying for your next quiz, then I'm not a very good teacher now, am I? Right? I don't think that should be on you to be like. Oh, right. Sorry. I got excited today. Today's a good day. I had my Mountain Dew on the way to work instead of after I got to work.
Oh,
It's kicking in. You guys get the full-blown caffeinated Mr. Mac. I apologize for this. You guys want to get sprayed yourselves? We can do that. Spray down. We need an eye wash station in every class, but it's filled with like hand sanitizer. Can you imagine that? You guys seen Matilda, the movie?
Yeah.
The $1 Million Sticky?
I love Matilda.
I have a cat named Matilda.
I'm sorry. Usually not in here, but in the hall.
Yeah, it really does. I think they're cleaning out the sewage. Yep. War does not determine who is right, but who is left. Oh, wow. That's a really good quote.
No.
That's a really good quote.
It was in the wrong. It doesn't matter.
How do you solve? We'll start the class with that. We'll start the class with a musical number, because why not? Everyone's asking me, why do I call every problem Maria? And I feel like we just need to get this out of the way now.
Did you not explain it yet?
All right, here we go. Someone hit the lights, please. Good idea. They're probably right.
Oh no, I can't do daily. I'm so sorry. Nelly, that is dangerous.
Yeah.
Safety first.
I better not start making noise.
I thought I was being safe.
She climbs a tree and scrapes her knee. Her dress has off a tear. She waltzes on her way to mass and whistles on the
Let me know if you're here. People online. Haley's here.
Her whimper, she has curls in her hair. I even heard her singing in the alley. She's always late.
So the idea is that this is a real story. It's about Nazis, but you don't know that to the end. This is set place in Austria as the Nazis are beginning to invade. So Maria is a nun at this abbey, but she doesn't really play by the nun's rules. So, for instance, she has curlers in her hair underneath her little, like, penguin hat, and that's not allowed, right? And so they're trying to kick her out of here, and the head nun is like, no, but they're trying to talk about what they should do about her. Okay.
But her penitence is real. She's always late for everything except for every meal. I hate to have to say it, but I very firmly feel Maria's not an asset to the abbey. I'd like to say a word in her behalf.
And say, Maria.
Maria makes me laugh. How do you solve a problem like Maria? How do you catch a cloud and pin it down? How do you find a word that means Maria? A flirty little will is a clown. Many a thing you know you'd like to tell her. Many a thing she ought to understand.
Only missing Nate from the online crowd.
How do you make her stay and listen to all you say? How do you keep a wave upon the sand?
How do you keep a wave upon the sand? You know what they're saying here? They're saying you can't. They're comparing Maria to something that you can't control, which I think is pretty important to think about because, you know, we got this online learning thing going on here, right? And they're like, we can't make them show up. We can't make them stay in class. We can't make them pay attention. How are they going to learn? This is awful. This is why online learning is terrible. And I hear that. And I think, well, how do you know that they're paying attention and learning and doing all that in class? Right? And we've talked about this. Yeah, right. Because their eyes are on me. That's what Olivia wrote about last week, right? Eyes on me. That's how I know you're learning. And it's BS, right? I mean, you can have eyes on me right now, and you're not thinking about me. You're thinking about Spanish, right? And God bless you, right? If I no, seriously, Mika, don't. I'm not mad at you for doing that. Just so it's over clear. If I cannot, as a teacher, distract you, and I distract probably the wrong word, enough to grab your attention, then that's on me. That's not on you. At least that's what I think. I think online learning reveals the problems we've had this whole time that we've just been sweeping under the rug. I talked to somebody back at the beginning of the school year, and they're like, we cannot go to online schooling because if we do, Remember what happened in the spring? We lost so many kids. Let me say that again. We lost so many kids. We lost them. What does it mean to lose somebody? I think that's ironic, don't you? We went to online learning to avoid a virus, but we lost so many kids. And I asked, who died? Oh, no one. We just lost them educationally. They were already lost. Why did you think they were learning before? Well, because their eyes were on me, and they had attendance. Their butts were in the seat. Of course they were learning. And they got an A. We are deluding ourselves. Online learning is always going to be worse than in-person learning, and here's why. Imagine you're online and you want to do something in person. You can't, right? That sucks. Now imagine you're in person and you want to do something online. Oh, okay. So automatically, in-person will be better, right? It will, automatically. But I don't think it has to be this gigantic gulf. It could be a lot closer. Learning math without seeing my hands moving around and seeing me is difficult. And Google Meets doesn't have this built in where you can see me and the screen at the same time. I have to go out of my way to figure that out and finagle it. But I think it makes a difference. We have these cameras now finally for teachers, but they're useless because most teachers are just sharing their screens and they can't use the camera and the screen share at the same time because they don't know how to do it, right? Well, they don't have the internet to handle it, or all these different things. But that isn't why online learning is bad. It's because we didn't prepare for it. We had all summer to do this, and instead we focused on coming back to school and half-assing it. Teaching online and in person at the same time. And that's fine because we need to plan for that, right? But we didn't plan for the inevitable. And so when you talk about how kids are like, we got to bring them here, we got to do this, and online learning is terrible. Well, of course that's the way parents feel. Of course that's the way you feel. Of course that's the way teachers feel. Because we made it terrible. Or at least a lot worse than it had to be. And so when they're eager to get you back in school and they're eager to get back to normalcy, remember that. It wasn't a fair fight to begin with. They'd already made up their minds. One way is going to suck, and the other way is going to be, well, what it normally is. Which is great, because look, they're all in their seats. Their eyes are on me. So how do you keep away from saying, well, you can't keep Maria, you can't control Maria, you can't control kids. And whenever you try to do that, and whenever teachers go to a conference about how to motivate your kids, load of baloney, you cannot motivate someone. Eventually the carrot's no longer appealing, because why would I do that to get a carrot when I already have 12? I'm bored now. I already have the A. Or the sick, we're going to give you a bad grade. I'm already failing everything else, bud. Eventually they don't care. And every time you do that, it kills their intrinsic motivation, their love for learning, what you felt in kindergarten. And then we're really screwed, right? We're digging a hole to get out of it. How do you solve a problem like Maria? I tend to assume most problems are unsolvable until proven otherwise. But that doesn't stop me from trying to fix them or trying to figure them out and learn something from them. And I think we can learn something from this. How do you solve a problem like Maria? How do you get her to fit into a nun's clothes and act like a nun when she isn't? I think that's what they're asking.
Oh, how do you solve a problem like Maria? How do you hold on in your heart?
How do you hold a moonbeam in your hand? Think about that concept. Holding it in your hand is ownership, right? I want to own that moonbeam. First of all, the question is why, but we'll ignore that for a second. Right? What do you want to do with it? Sell it? Bottle it? Stick it in a stew? What makes the moon special? Well, there's lots of things, but one of the things that makes it special to me is that everybody on Earth gets to see it. For free, every day, night. And as soon as you want to hold it in your hand, you want to have it for yourself. You're missing the whole goddamn point. And I feel like we're doing that in education. All right, so let's talk about subtraction. Mika, you're doing a really good job. This is a challenge today. Again, I'm not, this isn't like, I'm mad at you. We're clear, right? I know a lot of teachers would get mad about this, and so when I... Okay.
I don't like none.
Okay, cool. Oh, I'm sorry, neither do I. But like, I just want to make sure, because I know like a lot of teachers would get mad, and so when I don't, it's like, is he being sarcastic? I'm not. It's really cool. A little bit of delay on that. Alright, so let's talk about subtraction. So earlier this morning, I have kids come in for algebra 2 like, we got a quiz today, I don't know what it's about. It's some find the slope when you're given 2 points or whatever. But you guys might remember this thing. I know. Remember that at all? Sort of? Right? You had to memorize it, you don't know what it means? What does M stand for? Yeah. Slope. Wait, why? Why? It starts with S. In French, slope starts with M, I guess. In the French, they use that. S also looks like a 5, so we try to avoid that, right? What is slope? You have Wi-Fi now?
Hey.
Hey, buddy. Hey, buddy. Congratulations. Internet should be free for everybody. It is a public good, especially in these times, just like education. Anyway, in fact, they're one and the same now, aren't they? Anyway, excuse me. What is slope? What is slope? No smiling, Annie. It's math class. What? Yeah. How steep it is. And we measure that, right? If it goes up more than it goes over, that's really steep, right? If it goes up a lot more than it goes over, it's really steep. If it goes over a lot more than it goes up, it's not very steep, right? So it has to do with the relationship between how much it goes up and how much it goes over, otherwise known as the what? Come on, you didn't memorize this? How many years have you spent doing this and you don't know this? Crazy. I don't blame you, by the way. Okay? How much it goes up, how much it goes over. What are we talking about? The, over the. This is how normal math class works, right? They have fill in the blank and they just wait for you to answer. And then once you get it, they go, yes, good job, we all learned today. Yeah! Woo! Oh yeah! Woo! Everybody did! Okay, so rise over the run. And then they move on. Okay, fine. That was the learning. That's what happened just there. What you saw, that was learning. Rise over run. What does that mean? Well, it's how much we go up vertically, right? That's what rise is. Vertical. Run is the horizontal. So we have the vert over the horizontal. Memorization is a natural thing that happens after you learn. I have this memorized because I've used it so much. I actually forgot it this morning. I had to think about what it meant. Vertical over horizontal, that's what that stands for. Now, which variable deals with vertical, class? The x or the y? Which variable deals with the up and down, the vertical? X or y? I ask the questions, which variable deals with the up and down? I ask the questions, which? It's the y variable. You got jokes. And so x deals with horizontal, right? So it's the vertical over the horizontal. And we're not just talking about vertical in general, we're talking about vertical distance. You dig? Right? How far it went up, the distance. You know what I'm saying? Smell what's happening? This is vertical distance over the horizontal distance. How far it went vertically, how far it went over, right, horizontally. I'm thinking of two numbers. You're going to think of them too now. I'm thinking of 7 and 5. How far are they apart? The distance between 7 and 5 is 2. The distance. What do we do to find the distance between two numbers? How'd you do that? Yeah. Subtraction is distance. Hold on. We're not done. What is that? What is that? What is that? What is this? Don't make fun of me. It's a subtraction sign. So this is, subtraction is distance. Y deals with the vertical. This is, subtraction is distance. Y deals with it's vertical. It's vertical distance. Vertical distance. You're telling me slope is the vertical distance over the horizontal distance? No, duh! That makes sense. I want to know how far apart these two things are vertically. So what am I going to look at? Their y values, how far they are vertically. I want to know how far they are apart horizontally. X values. Distance. Oh. That's where the formula comes from. Someone didn't just make that up. I mean, they did. They thought about what it meant. That's how you come up with the formula. People that are asking about E equals MC squared, how did he come up with it? That girl on TikTok, how'd they come up with math? They did something that we don't ever do in schools. They thought about it. Subtraction. There's another thing I wanted to show you, but I know I'm boring you. Subtraction is distance, ladies and gentlemen. Number line. Give me two numbers. Blake. You what? 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 Blake, give me a number. Good job. Okay, I'm not going to put the 5 down yet. Does anybody know why? Okay, you will in a second. Marissa! Give me a number. Okay. Why did I wait to put the 5 down and the 2 down? Uh-huh. Right? Left is small, right is big. That's traditionally how we do it. If I put 5 over here, then I don't have a lot of room for that too, do I? Okay. What's the distance between 5 and 2? Well, the distance is whatever this is, right? This idea of this thing right here. How do we figure out the distance between these two numbers? No, you're not in math class. Eyes on me. Please don't stop looking at me. You subtract them, right? Now, how do I know I need to subtract 5 from 2 to get the, or 2 from 5 to get the distance? 5 minus 2. Why not 2 minus 5? What's wrong with a negative number? Oh, I screwed up the colors. Darn. What's wrong with a negative number? That's negative 3, right? And this is positive 3. What does a negative sign mean? That's different than subtraction, by the way. It's different. Negatives are different than subtraction. They're related, but they are different. What does a negative sign indicate? Below 0, the direction, right? If 0 is center, anything to the right is positive, anything to the left is negative. So this is just the distance going this way, isn't it? Right? From 5 to 2 is minus 3. We're heading to the left. From 2 to 5 is positive 3. We're heading to the right. That's it. That's all negative numbers are. It's direction. Now, for distance, do we care about direction? If I'm driving to Fulton, or you're driving from Fulton to here, do we care how far or which way you're starting in order to determine how far it is? Not unless your grandparents are talking about how we used to walk to school from Fulton, you know, uphill in the snow both ways, right? We don't care about direction. 5 miles there is 5 miles from here to there, right? Vice versa, same thing. So what we usually do is we assume that distance is always positive. We do this thing called absolute value. You guys remember that? Right? Makes it all positive. Really, it's just we use it for distance. And the reason for this is this. Imagine I wanted to go to 7 next, right? If I calculated the distance between 2 and 5 to be negative 3, and then I traveled further to 7, right? Distance of 2. Now I've got negative 3 plus 2 for my total distance, right? And that's going to give me a negative number. I went left. Uh-oh. That ain't right. That boy ain't right. You know that show, King of the Hill? Now ain't Bobby? So we assume distance is positive because it makes it easy to add. Because when you add, you can add in any order, right? It's the negatives and minus signs that screw it up. Okay, great, awesome. Let's get to the point. How would you solve a problem? Whoops. How would you solve a problem like Maria? Come on, anybody. Feel free. Even the people online. Sorry, I've been ignoring you. How do you know? You count on your fingers. How did you do that? Can you walk us through that process? I know that can be difficult. Seriously, I'm not joking. So you counted backwards. You counted backwards. That's one way to do it, right? So basically what you're doing, so we have a direction dispute. Okay, so you're counting backwards 7. 1, 2, 3, 4, 5, 6, 7, and you're counting the numbers. So you're going to left. Okay, you said you counted the other way?
Yeah, you count up to the count. Yes, I can't think backwards.
So Laura Lee is counting up. In other words, she's doing what? She's counting the distance, right? She's counting how far it is, from 7 to 21. Isn't it weird that if we want to know the distance between 7 and 21, we have to do 21 minus 7? I'm going to say that again. If you want to know how far apart 7 is from 21, you have to do 21 minus 7. It flips it, doesn't it? Right? Here, you're asking the question, Corinne, what's the distance between 21 and 7? And so you do 7 minus 21, you're going backwards. You get a negative answer. Negative 14 is how far we're going, right? And then you make it positive because you're like, okay, but I actually wanted to go the other direction. I wanted to go this way, right? So you can do it two ways. You can think 21 minus 7, or you can think 7 minus 21. The only difference between these answers will be what? No, they'll both be 14. What's the difference? One's negative. It's direction, right? Am I starting on 7 and going to 21? Well, then 14 is the distance. Am I starting on 21 and going to 7? Well, then negative 14 is the distance. If you flip which way you start, all you need to do is flip the sign when you're done, right? Because it changes the direction. That's all the sign means, direction. So maybe if I gave you this problem, 7 minus 21, you go, right? But it's just this with the sign changed, because you're going the opposite way. Instead of starting on 7 and going to 21, you're starting on 21 and going to 7. That's all it is. What's another way to think about this? So far, so good. Give me another way. How else would you solve a problem like Maria? I can't believe no one's said this yet. Come on. I'm setting you up. How would you do it? You cross something out and carry. You carry your cross. Sounds fun. How would you do it? Mika, are you not studying your Spanish? I want for the record.
No, I did.
Okay, she did. And now what is she doing? What are you doing? You're here, right? That's a lot better than being like, no, you can't study her Spanish, and then she's studying in her head the whole time, which takes a lot longer to do, and it's a lot worse. It's not as good. Better just let her do it. Why does teaching have to be a power struggle? You guys, I'm sorry I keep bringing you up. I hope it's okay. Are you okay? All right, cool. 21 minus 7, how would you do it? Something about borrowing and crossing, yeah? Give it a shot, go ahead.
You cross out 2
Okay.
and then you put 1 in front of the 1.
Okay.
Right?
Yeah, sure, why not? You guys remember that? Borrowing from the 2. What's going on here? What is this witchcraft? Satan! Thanks, Parker. That's bad for people that have lots of money, but for you and me, it really doesn't matter. Stock market is a hoax. So, what is going on here? What does that 2 originally stand for? 20. Now what does that 1 stand for? 10. What does that 1 stand for? The small one.
1.
Does it? What do you do next? What's next, Olivia? What do we do next? 11 minus 7. How would you do that, by the way? Count up. 7 to 11, the distance is 4. That's why your method works, right? How else might you do it? Yeah?
A lot of the time when I do math like this, I just subtract the number from 10.
So you're going to do 10 minus 7, or what are you doing?
10
Explain.
minus 7, and then I just add the 1.
Ooh. Isn't 10 plus 1 the same thing as 11? And then he subtracts 7, right? That's what we're doing here. 11 minus 7, right? But he's saying 10 minus 7 is 3. Then I'm going to add back the 1 that I took earlier. If that's hard for you to understand, let me show you this. What if we did 10 minus 6? Isn't that the same thing as 10 minus 7? Or 11 minus 7? 10 minus 6 is the same thing as 11 minus 7. What do you notice? Yeah.
Both numbers are 1 less.
I changed the numbers by 1, right? Now think about that. Imagine, if you will, 2 points on a number line. And I can tell you what they are. This is their distance, right? How far they are apart. Now what happens if I add 1 to both those numbers? Did the distance change? No. Here's two numbers, they're this far apart. What happens if I subtract 5 from both those numbers? Did the distance change? No. 11 minus 7 is the same thing as 10 minus 6, and I can do 10 minus 6 in my head. I'm changing 11 to 10, which means I need to change 7 down 1, which is 6. 4. Ah. We call that shifting. How long have you been doing subtraction? Your whole life, right, basically? And they never thought to bring this up once? What were they doing the whole time? Okay, class, now we're going to memorize more subtraction facts. Right? 10 minus 7, 3. 10 minus 8, 2. 10 minus 9, 1. Blast off! And you do this every day for the rest of your life. And we call it learning math. What's going on here? 11 minus 7 is what's happening, right? So this is a 1 that stands for a 10, yeah? What does that 1 stand for? The little 1? It also stands for a 10, doesn't it? Right? We borrowed a 10. And then we have this 1, which stands for just a regular 1. And then we're subtracting 7. 10 plus 1 minus 7. I crossed it off, but you see that? That's what's happening. And when he did it, it felt like a trick you didn't understand. And when you did this, you're like, I don't understand that really either. But I know how to do it. 10 minus 7 is 3. That's 14. That's what's going on here. That's it. Except they're thinking of it as 11 minus 7, which is a little bit harder, right? That's one way to think of it. But you could also do this. That's the same as 10 plus. Let's do 10. How do I want to do this? I don't want to do this. We'll do 10 plus 1 minus 6 minus 1. However you want to do it, whatever makes sense to you in your head. Here's another way. Here's another way. Let's not borrow. We don't need to borrow. The world is yours. What's 1 minus 7? Think about this. I'm asking the question, starting on 7, going to 1, what's the distance, right? 1 minus 7, what's the distance between 7 and 1? 6, but we're going from 7 to 1, so it's... What is this, witchcraft? That 2 stands for what? 20. What's 20 minus nothing? Oh my God! Illuminati confirmed.
Why didn't anyone tell us this?
Why do we have to borrow? It's a 1 minus a 7 and a 20 minus. See, look.
Like, I feel like if I knew this in like 3rd grade, I would be a lot better now.
You want look? We did 1 minus 7. What's easier? 20 minus 7, 13. I don't know. Do what you want. Oh my God! Why? Instead, we give you a timer and we give you a test with a bunch of these, and we say as fast as you can. And what can't you do if you have to do it quickly? Think. This is math. Why don't they love it? Why aren't they showing up on stream? Don't they want to learn? Yeah, they do. That's the problem. No, they're just lazy. I mean, sure, we all are to some extent, but what made them lazy in the first place? Kindergartners don't come in lazy. You guys want to do math? Yay! And then we do it and they go, oh no! I don't think I'm a math person. I only got 5 right on the test. This is good, and we should keep doing it. Subtraction is distance. That's one way to think about it. You can borrow. You can just think about the problem differently. Do another one. This one I want to look at my notes from earlier because I came up with a really juicy problem. It was on accident. I don't think I can replicate that again. The magic was, you know when it's just magic? You're just like, that's just never gonna happen ever again. That was so beautiful and wonderful.
Oh my.
I think it was the one I crumpled up. And then missed. Dang it! Oh, there's a chance. There's a chance. I think I got it. I think I got it. How would you solve a problem like Maria? How would you solve a problem like Maria? Collective you. Sorry, we don't have that in English. We do in Spanish, though. At least the Spain version of Spanish. Ustedes. It's that, when you conjugate verbs, it's like yo, to, and then there's like the he, she, it, right? Then there's the we, and then the they, but there's no like middle spot over here. That's the plural you, right? There's I, and then there's we, right? It includes myself, but it's plural. Then we have the he, she, it, singular you, right? Or singular them, right? And then there's them, which is plural them. And then you have you, and there's no plural version of you. It's y'all, basically, right? Spain has that, we don't. The South does, y'all. It's the inclusive you. You people, right? How do you solve a problem like Maria? How y'all do that? How would you do it? There's plenty of different ways. And don't be afraid to experiment. Play with your math. We've learned a couple methods, right? Counting up, counting down, carrying and borrowing, thinking of it as distance, flipping it around and then changing the sign. I probably wouldn't want to flip that, right? 76 minus 154 sounds a little bit more difficult. Any ideas? That's okay. I know we've now officially done a second problem in one day. I know that's not really how I do things. Usually just one. Maybe something to write about in your portfolio if you're not sure. Yeah, go ahead. You got an idea?
Subtract 76 from 100, then just add 54.
$76 minus 100. Let's estimate. It has to be less than 30, right? Because 100 minus 70 is 30. So it's 20 something. It's going to be 20 what? 24, right? 4 and the 6 make 10, right? So that's 80. I'm counting up now. I'm using Laura-Lee's method. 4 and 6 gets 80. 20 more gets 100, right? So that works. 24. The only thing funnier to that is what?
25.
And then there's lots of ways to do that. 78. Oh, I was off by 9. I wanted 9. Okay. See you guys later. I would encourage you to write about this today and not wait on it. Do that in your next class.
Hey, it's
Bye.
a gravy vessel. I didn't know what's still in here.
Yeah, I keep my grandfather in it.
Oh, very
Hola, buenos
nice.
dias.
Add some flour.
Oh,
and
very
sweet
good.
trimmings and- Yeah.
It's 145. That was the problem. Darn, I mixed with some numbers. 145 minus 76 is the number I wanted. See you later. Bye. Love you all. Today we're talking about subtraction. Right down these desks. Hello. Good morning, Vietnam. Looks like we've got all three of us here today. A huge amount of debt and not be taxed? That's not how that works. I have a huge amount of debt and I get taxed. That's not how that works at all.
Mr. Mack, we do math today because actually I do not want to do anything today.
We're gonna learn today. No promises about the math. First off, I want to answer a question that everybody keeps asking. Why do I call every problem Maria? Well, like most teachers, I've had former students that I really hate. And I had a student named Maria. Just kidding. Just kidding. Just kidding. And you go back to sleep, I don't know. My thought process, I had Mika Jacobs ask me, Mac, I've got a Spanish quiz next hour. Is it all right if we study? And I said, sure, why not? You can do whatever you want here.
Spanish?
If I can't distract you from studying Spanish, okay, then I'm probably not very good at my job. I distracted her. She paid attention and actually did almost the entire class. Actually, she spent the beginning of it reviewing, which is a lot better than saying no, and then she reviews it in her head, which takes a lot longer and is a lot worse. You can do whatever you want, guys.
I take Spanish too, and I'm hating it. I'll take Spanish too.
So let's do Tendi. And then I want to ask you guys how yesterday went. How did portfolio conferences go? What do you think? Suggestions, comments, critique?
I think mine was good.
Fine. Do you think it was helpful?
Well, I think it would have been better in person. But...
Better in person? Okay, I agree with that. We're going to talk about that today a little bit. My own critique was I felt like 5 minutes was a little rushed. It was more me talking and less you talking. And that's because I had to get to the next person. What I think the solution to that is, and you can tell me what you think, A-Day kids, B-Day kids, every other week we do stuff. So like week 1 might be A-Day kids have to do a portfolio conference, B-Day kids optional. Do you want critique? Show up, right? And then the week after that, B-Day kids will have to do it for a grade, right? I think that's fair. The problem with that is you're only going to get like 8 grades this semester then. But they're all changeable, so I don't know. Does that sound like we should try it? What do you think? Yeah? Any other problems that we need to address with that, or any, but you felt it was worthwhile? Okay. I hope you remember the critique and the conversation more than you do the letter grade.
You put our grades in the Skyward?
No, they'll go in this weekend after I cut up the audio and then paste the audio into Skyward. Okay. Hey everybody. People online, if you have any critique or anything to say, you can comment as well. Let's see. Let's do Tendi. I see Steven. I see Carter. I see Adam. I see Nevaeh. I don't see Cliff. Max. I see Rowan. I see Lindsay. I don't see Max. Don't see Josh.
Josh was like sleeping during the first hour.
Well, if you're friends with him, send him a message. That's the nice thing to do. While we're doing this, I heard you said it would be better if it was in person. I agree with that. I think everything is automatically better in person, and here's why. Imagine you're remote learning, right? And you want to do something in person. Well, you can't, right? Now imagine you're in person and you want to do something online, right? Automatically in person is better because you can do online. Like imagine there's a situation where online would be better, right? Everybody got your Chromebooks, right? We can do that. So automatically it's going to be better, always, because you have more options. However, I think the drasticness of the quality between in-person and remote doesn't have to be so drastic. For instance, when I'm moving around doing stuff, I bet it's more engaging than looking at somebody's screen as they talk in a monotone voice, because they know you can't see them, right? Now the problem is in order to get me here in the screen as well, I have to really go out of my way and finagle stuff to get Google Meets to deal with that. I have to go through special programs, all kind of stuff. So it's great that we have these cameras now that took, 4 months to get here. But your teacher can't really use them because it's the choice is between looking at me and looking at what my screen is, right? So already it's further removed from in-person because you're not even seeing the teacher now, right? On top of that, they don't have document cameras. I bought this 4 years ago when my school threw them out because they're like, oh, that's old technology. Joke's on them. It's 2020 now. I bet they wish they had those, right? So I don't think it has to be as bad as it is. I think there is a difference, and that's true. Definitely in person is better. But I don't think it has to suck quite so much. I don't think we really spent a whole lot of time trying to make it not suck so much. We were too busy trying to half-ass this, teach in person and teach remote at the same time, to think about the inevitable, what happens if we go fully remote. And so I think it makes it worse than it has to be, which is why you guys hate it so much. It's almost like we made it worse on purpose. Anyway, one of the main problems for teachers, at least, when it comes with remote learning is how do we make them show up, right? They're not really there. We gotta make sure we see their faces, and they gotta put a timestamp, and I feel like that's really good, but that sounds like the business of surveillance, and that's not what I'm here for. Compliance. What you're told. And they're like, well, how can we know if they're learning or not if they're not there? And it's funny because how do you know if they're learning in class? How does your teacher know you're learning in class? How do you think? What do they look for? You ever heard the phrase, eyes on me? So I'll know that we're all learning or we're all paying attention. Look at me and think of something else that I'm not talking about. What do you mean, Mr. Mack? I've been doing that the whole time, right? But yet they think, oh, yeah, we're learning. Look. And look, she has an A. She's learning. Her butt was in the seat and she was staring at me. That's how I know. The problems of remote learning, most of them, are problems that we already have in school. We just sweep them under the rug, right? It just makes them apparent. And we don't like that. That's what we're upset about. Everything was perfectly fine before. So when they try to say, go to a conference for teachers, how to motivate your students, all a bunch of BS. You cannot motivate someone else. If you try to do that, you're either doing it typically with a stick or a carrot. You know the expression, right? The stick, whack them, right? Make them do it. The carrot, here's a reward. They're referring to as horses, by the way. Work animals. Love that. Eventually, after, getting 37 carrots, you get full, or you have 37 carrots sitting here because you didn't like them anyway. And why would I go out of my way to get the 38th carrot, right? In other words, I already have an A. Why should I do more? I have a B. I'm fine with a B. Or whatever letter grade is your favorite flavor. The stick. I'm going to beat you. You're going to hit you, right? You're going to get a detention. You're going to this. We're going to call home. You're going to get an F. Who cares? The kids that are getting Fs, it's not because, oh man, I really hate Fs, and that's teaching me. They don't care. Because why would they? School doesn't work for them. I'm not smart. I'm not going anywhere. What's the point? Well, you need good grades to get into college. I'm not going to college. Why would I? But this system is fine. How we know they're learning. And if they're not, we can kick them in shape by giving them an F. Or calling home and pissing off their parents. That's not how you do it. And every time you smack someone, every time you give them a carrot, there's less reason for them to try more later on. It kills their intrinsic motivation. You know when a kindergarten shows up to school and they're so excited, yay! You say, let's do math, everybody, woo! Here's your homework for a grade. Ooh. Everybody says around like 4th grade, 5th grade is when it all went downhill. You know that's the time we start introducing grades. We start upping the homework. The time we start ranking you guys, we start doing time tests. Here you go. Good luck. When you do things quickly, what don't you have time to do? Think. How do you solve a problem like Maria? Is this phrase I use a lot, right? And it comes from this movie, The Sound of Music, which is about Nazis. You don't realize this to the end, but this is taking place right before Austria is invaded by Nazi Germany. It starts out, lighthearted, and at the end, you see what's going on. And I think as a little kid, I'd watch it with my grandparents, and we'd watch it late at night, and I'd fall asleep before the end, and I never really realized what was going on. But as I got older, and we'd watch it with my sisters who are younger, and we watched it together, I started to see. The movie starts with this free-spirited nun. She's wearing nun's clothes, but she is not a nun. She just isn't. She was not born to be. That's not who she is as a human being. It is not in her soul. And so they're debating, how do we solve a problem like Maria? How do we get her to be compliant? How do we get her to be a nun when she's not? And they sing this song.
She climbs a tree and scrapes her knee. Her dress has got a tear. She waltzes on her way to mass and whistles on the stair. And underneath her whimper, she has curlers in her hair.
Curlers.
I even heard her singing in the abbey. She's always late for chapel, but her penitence is real. She's always late for everything except for every meal. I hate to have to say it, but I very firmly feel Maria's not an asset to the abbey.
I feel like you guys are Maria and we're the nuns. You're always late for everything except for every meal. You're late for everything except for recess, right? I wonder why. They got curlers under their hair. They're wearing their hats in school. Well, that's disrespectful. Can't have that. Singing in the abbey. No happiness in school. And they're trying to solve this problem, right?
I'd like to say a word in her behalf.
That's the good thing.
Maria makes me laugh. How do you solve a problem like Maria? How do you catch a cloud and pin it down?
Her response, the head nun. How do you solve a problem like Maria? How? Same question is, how do you catch a cloud and pin it down? How do you do that?
Catch a cloud and what?
How do you catch a cloud and pin it down? You can't. See what she's saying here?
How do you find a word that means Maria?
Lazy. Right? All the things they say. That's why they're not showing up.
Anything you know you'd like to tell her.
Authority.
Anything
Conformity.
she ought to understand. But how do you make her stay and listen to all you say?
How do you make her say and listen to all you say? Sound familiar? Sound familiar?
How do you keep away upon the sand? Oh, how do you solve the problem like Maria? How do you hold on in your hand?
How do you hold the moonbeam in your hand? If you're asking that question, you're asking the wrong question, because one of the things that makes the moon so great is the idea that everyone everywhere, at least once a day, gets to see it for free. The same moon. This beautiful, magnificent thing up in the sky that no one can own. In fact, it's illegal that we have a U.S. flag up there, internationally speaking. How do I hold that moonbeam in your hand? Why do you want to hold it in your hand? You want to bottle it, stick it in a stew, sell it? Own it. You're missing the whole goddamn point. The moonbeam is cool because it's the moon. Holding it in your hand defeats the purpose. As soon as you can do that, it has no worth. This is what we are doing. We're missing the whole goddamn point. Education is not about compliance. It's antithetical to that. It's the opposite. If you have compliance, you can't be learning. So when they try to get us all to go back to school 5 days a week, no masks, go back to normal as much as they possibly can, remember that the way they did this is they convinced you that online learning cannot work. Why? Because we made sure it couldn't. How do we know it doesn't work? Well, they're not, butts aren't in the seats, eyes aren't on me. Their grades aren't as good. When those things never indicated learning in the first place. These problems always existed, we just swept them under the rug. And now, because of online learning, God bless it for all the crap it is, but all the good it is too, it showed us the truth. You weren't learning in the first place. And we just wish we could go back to the good old days. Hi, Cliff. So, that's what I mean when I say, how do you solve a problem like Maria? Yes, Geneva. You may, anytime, you never need to ask, ever. Okay, just not in here. Okay, I had a kindergartner right there on the circle rug, right there.
Look raw.
How do you solve a problem like Maria? What problem are we going to talk about today, kids? Well, we're going to talk about subtraction. How long have you been doing subtraction?
That's how it was. Third grade.
I know, right? I'm going to blow your freaking minds today. So, this morning, okay, total impromptu. Oh yeah, wrong way. How do you do subtraction? What do you think about it, right? I had these kids come up to me. They're algebra 2. They got a quiz today. Like, oh man, we got something. They got to find the slope of the line, given 2 points, right? You guys remember this? You probably don't. You might remember it. What's your reaction?
I hate that.
Yeah, exactly. Right? Yeah, exactly. Right? What does the M stand for? Boys and girls? Does anybody remember? This is what regular class is like. I wait for you to answer the question, and then you get it right finally. Oh, close, right? And then we move on. What does the M stand for? Any idea? You remember? What if I say y equals mx plus? Slope, exactly. Now the question is, why is the slope? Slope starts with S. Well, it turns out the French named it, and the word in French was M or something, right? Also, S looks like 5. We try to avoid that. Nice job, Grace. So, good job, everybody. This is learning. That's not the point. That would be where the lesson ends, right?
Literally.
So, slope, right? Now, what is slope? What's the idea of slope? Like, can you explain me? What is this? Any idea? Okay if you don't, but take a crack at it. I only got 2 people in class right now. Geneva bailed, so.
I remember what I did last week, let alone last year.
Yeah? What do you think? Where it goes, right? Okay, sure, something with the graph. What about the line? The steepness, right? Like slope on a hill. Does that make sense? Right? How steep it is versus how flat it is. Now, how do we judge slope, steepness, right? If the line goes up a lot, but not very far to the right or left, right? It goes a lot vertically, but not a lot left or right, then it's steep, right? This is a really steep hill, you dig? Right? It's because it goes up a lot and over very little, right? If it goes over a lot, but up very little, it's not very steep, right? It's pretty flat. What we're talking about is how far it goes up, how far it goes over. How far? When I say how far, what do you think? Well, obviously Moana, but like next thing, what's the next thing? How far? Come on. Like what? Distance. Ah, distance. Okay. Slope has to do with distance, right? 2 types of distances, right? How steep or how not steep, right? Vertical versus horizontal. You missed something key, but you'll be all right. Okay. It has to do with how far we go up and how far we go over. The what over the what? The rise over the run. So, slope has to do with how far we go up. We call that vertical distance, right? And then we have horizontal distance, right? If it's really vertical, it's steep. If it's not very vertical, but it's a lot horizontal, it's pretty flat, right? That's the idea. Class, which variable, x or y, deals with the vertical distance? Which variable deals with vertical, x or y? I ask the questions, which variable, x or y, deals with the vertical distance? Which variable deals with vertical, x or y?
Why?
I ask the questions. Which variable? It's the y variable, right? Which one deals with horizontal, left or right? Well, it must be x, right? And you said earlier, how far means distance, right? Okay, let's talk about distance. Let's talk about distance. Give me a number, Geneva. 37. Give me a smaller number, Maddie. 11. How far are those numbers apart? What's the distance between 37 and 11? What are you doing in your head to figure it out? Subtraction. So what you're telling me is subtraction is distance, aren't you? Subtraction is distance. Which variable deals with the vertical? Which variable deals with the vertical? I asked the question. Which variable deals with the horizontal? Very good. Now, class, that would be where that lesson ends, right? So you're telling me subtraction is distance and the y variable deals with the vertical? Oh my god, what is that? What is that? It's the y's in subtraction. It's the vertical distance, isn't it? It's how far apart they are vertically. Oh. No yawning in math class. That's the vertical distance. How far apart they are vertically, yeah? That's how far apart they are horizontally. Oh my God. Vertical distance over horizontal distance. That's what slope is. It's the rise, how far we went up. How far distance up, y value, and how far we went over. Over is horizontal, distance is... That's what, it's rise over run. And you dummies don't remember this on the quiz. You know why? Because you never knew what it meant. You're looking at this, well, m equals y about 2 minus y1 over x to it. It is. So, this was earlier today, Algebra 2, someone was asking, like, we had a quiz, it's coming up, right? So I explained what this was, right? It's rise over run. Oh. Vertical distance over horizontal distance. Distance is subtraction, vertical y, so the y's go on top. Understanding. Now they have this memorized because they've done it so much, like I do, right? I've done it so much. Memorization is a natural thing that happens when you do it so much. But it wasn't where I started. I didn't try to memorize it first. I tried to understand it. Now it makes sense. In fact, I screwed it up this morning. I had the x's on top. And then Katie, who was in my class last year, was like, wait a minute, it has to be y's on top because it's rise. That's knowledge. You can question the teacher. Why are we talking about this? Because today we're talking about subtraction. And subtraction is distance, yeah? So when we're asking a question like 7 minus 5, what we're really asking is, how far apart is 5 from 7? Distance is this thing. How far are they apart? Well, it's whatever 7 minus 5 is. Now, check this out, check this out, check this out. I start on 5 and I go to 7. How far did I move?
2 spots.
2 spots. But what if I start on 7 and go to 5? Subtract 2. In other words, if I'm going on 7 and, and moving to 5, I'm starting on 7 and going to 5, I'm asking the question 5 minus 7. So subtraction is a little weird. Where you start is actually the second number, right? 7 minus 5 is asking, starting on 5, going to 7, 2. 5 minus 7 is saying, starting on 7, going to 5, we go back to. So negative signs are different than subtraction. They're similar, but they're different. Negative implies direction, right? It implies left. We went left to. Whereas positive implies going to the right. So again, distance, and it matters where you start in math world, right? Starting on 5, going to 7, the distance is 2. But starting on 7 and going to 5, which we would write 5 minus 7, it's flipped around, right? Starting on 7, going to 5, left, negative 2. Okay? Okay. Now notice that these numbers are the same except what? Their direction, right? They're negative sign, right? One's negative, one isn't. So you can think of whichever one's easier. If I ask you 5 minus 7, that might be a harder problem than 7 minus 5. But if you think about which way we're going, 5 minus 7, I know it's negative, right? So we're heading to the left. So it's the same thing as 7 minus 5, but heading to the left. Negative 2. Or you smell 107 in here. The answer could be negative or positive. Negative, we're heading to the left, right? Even when it's really difficult, you can think about which direction it's going to go. Okay, great. So this is the same as this. We just have to remember our answer is negative because we're heading to the left. Right? 235 minus 117. How might you do that? Well, maybe you subtract 100 first. We're now at 135. 135 minus 10. 125. 125 minus 5, and then minus 2. 118. So I broke that down by place value. That's another way to think about subtraction. And again, I know it's negative because I was supposed to be heading to the left. Regular distance, we don't care about direction, right? If I'm going to Fulton, you're going to Fulton to here. It's the same distance, right? We always assume distance is positive. The reason for that is this. If I wanted to go to 7 and then actually go to 8 afterwards, if I said the distance from 5 to 7 was negative 2, because it doesn't matter, right? And then I go one more. Now my answer is minus 2 plus 1, negative 1, right? I went to the left? What? So it's easier to think of distance as always positive in math, which is why we did the absolute value thing. You guys have heard about that, right? The two lines. Makes everything positive. We use that because distance always needs to be positive. That way you don't make that error, right? I started on 5 and went to 7 and then went to 8. Don't tell me that's -2 and that's +1 and tell me we went to the left, -1. That's the difference. All right. How would you solve a problem like Maria? How would you do it? What would you do? Lots of ways to do it. Any way you want. Experiment if you want. Famous verse in the Bible that talks about how everything is permissible. You can do whatever you want, but not everything is beneficial. You can do whatever you want to try and solve this problem. Doesn't mean it's going to work out, right? But please, focus on that first part. Everything is permissible. This part of the Bible is talking about how it's okay to eat pig, right? And anything. Who cares? Doesn't mean it's good for you, right? I mean, you eat crap, you're going to feel like crap, but like, you can. Who cares? You make the call. Same thing here. Anything is permissible. What do you think? What do you want to do? How would you solve a problem like Maria? You okay, Geneva? You having a good time? You all right? Okay, good. I want to check. I know I'm a lot. And it's very early. What would you do? Y'all heard of this method? The borrow, right, method? You know, borrowing. 1 minus 7, I can't do that. So what do? Yeah, so we cross this out and borrow, right? And we carry it over. We carry our cross. Sounds fun, right? So now we have this. Then what do? Ah, that's an 11. So what you're telling me is this 1 stands for 10. And then we have this one, which stands for 1. What does this one over here stand for? Wait a minute. If it's 1, then we have 12. That wasn't our problem. What does that 1 stand for? 10. Oh, sorry, the red one. See how that's a 10? Because the 2 before stood for a 20? Are you digging? Right, it used to be 20 plus 1, 21, right? Now we're thinking of 10 plus 10 plus 1 is essentially what we're doing. Or 10 plus 11, right? So we have 11 minus 7. How would you do that?
4.
How do you know? Ooh, you counted up. You went from 7 to 11, and you counted up. That's one way to do it. Why does that work? Because it's distance. I'm starting on 7, I'm going to 11. See, that was backwards, right? That was one way. Another way is to count down. Corinne did this. 10, 9, 8, 7, right? Again, it's just counting the distance and then remembering to make it positive because you went the wrong way, right? Okay, so 4. What about this? Now what do? Bring it down. But bring it down. Why are we bringing it down? Someone explain what's going on here. Why do we bring down the 1?
Is technically a 0 right there?
0. So we have 1 minus 0, which is 1, but that's not really what's happening. What's really happening? What's that 1 stand for? 10 minus 0, which is 10. So we do 10 plus 4, which is 14, right? Okay, that's one way of doing it, borrowing and carrying. Here's the thing, you don't have to borrow. The world is yours, baby. Go get it. Get that bread. We don't have to borrow.
That didn't work.
I need to draw a smile on here. Joker style. Yeah. Or I got these scars. All right. Let's not borrow. What's 1 minus 7? Think about it. I'm starting on 7, I'm going to 1. Direction matters. Starting on 7, going to 1. 6, but it's negative. What is this witchcraft? And that 2 stands for 20, right? What's 20 minus 0?
20. 2.
What? What? Dude, all we're thinking about is we're saying, look, this is 20 plus 1, and I'm taking away 7, or what are we, wait, hold on, what did I do here? 20 plus 1 minus 6 minus 1. And we're saying, look, that's nothing, and all we have is 20 minus 6. That's one way to do it. Check this out. What's 11 minus 7? Well, it's 4, right? Isn't 10 minus 6 also 4? What's the connection? Andrew. What do you notice? Andrew, you're here early, so hang around, okay? What's the connection between these?
Like 6, count up from 6.
Okay, sure, I see what you're saying. What else you got? Imagine 2 points on a number line. This is their distance, right? Now what happens if I add 5 to those points? Did the distance change? No. Imagine 2 points on a number line. I subtract 2 from those points. Did the distance change? 11 minus 6 is the same thing as 10 minus 4 because 11 minus 7 is the same, 11 minus 7 is the same as 10 minus 6 because all we did was subtract 1 from both of these, didn't we? We moved them both to the left, 1. This is a way easier problem. 21 minus 7 is the same thing as 20 minus 6. Way easier problem. It's 14. This is called shifting. Another way to think about it. What I want you to do is go back and watch second hour's video. We got a little bit further. Try and watch that. I would encourage you to write about this, getting you excited. I mean, we've talked about subtraction since we were like 5, right? And they never thought to tell you this. 21 minus 7, same thing as 20 minus 6, and here's why. Subtraction is distance. What are we doing the last 12 years? You don't think they could have brought it up once? See you later. I love you all. Have a great day. Good luck on your quiz, Geneva.
Have a good weekend.
Yeah, you too. Later, bud. See you tomorrow online. If you want. That was fun. Alrighty. Spray down these desks and we'll get to it. I saw that. That was weird.
Hey, guess what? I actually did part of my portfolio yesterday.
Awesome. You didn't meet with me though. That's not good.
Yeah, no. Sorry.
Yeah, actually. The genes are doing permissible, but not everything.
No, but you know what?
Yeah, no.
And he knows how to.
Good. Let's get to it. Today we're going to answer the question of what I mean by when I say, how do you solve a problem like Maria? Because it's come up so many times, people have asked, what are you talking about? But to answer that, we're also going to talk a little bit about slope. Why, you ask? Great question, because someone brought that up early this morning. I did that in the algebra quiz today over in Vanderbilt. I'm like, okay, what's going on here, right? I thought it'd be a good intro for today.
You know, this just
So
looks
we
like
didn't slope last year.
water.
Sorry.
Actually, I do want to go back.
This looks like Windex. It looks like.
It's going to be fun, you're going to love it. It's math, what's not to love? We have a lot to talk about today. Interesting things, I hope. I hope it will inspire you to start writing in your portfolios, and then we can talk about and get on.
I did that yesterday.
I know.
Yeah.
First thing we're going to do
See
is
how I
talk about
made this.
how the portfolio stuff went. We got a
Wrong one.
I don't care. It's recyclable.
I'm gonna say we gotta eat it today.
I'm gonna have.
All right, so we're going to do Tendi. while I play this little video. Again, people have been asking me what I mean by how do you solve a problem like Maria. Now, my veterans in here should know it more or less. You only had half a semester, you only had half a semester, right? You only had half a semester. But my veterans in general should know, the rest of you won't. That's most of the people online. I'm going to do 10 minutes while we play this. I'm going to talk about this video. I'm going to pause it a lot. I hope that doesn't annoy you. I know y'all want to get to your math.
Oh yeah.
Here we go. Oh yeah, oh yeah. Oh yeah, buddy. Oh yeah.
Yep.
Oh yeah. Oh yeah. All right, so the context for this. This is a movie. It's not a moving picture. No, okay. So, I used to watch this with my grandparents. It's called The Sound of Music. It's this movie about Nazis, but you don't realize that to the end. And I was so young, I'd probably fall asleep before we got to the end of the movie and realize what was happening. But now watching it as an adult, I realize what's happening behind the scenes. Now, Nazis are all about compliance and all this stuff, right? And they beautifully choose to start the movie, metaphorically choose to start the movie, with the main character being a nun that really isn't. It's not in her soul. It's not who she is. And they're trying to get her to be a nun. And they're debating what they should do about it. They talk about some of the things she does that just aren't very nun-like, and how they're going to solve the problem that is Maria. And again, if you think about this, this is a metaphor for Austria, which is about to be invaded by the Nazis. How do they solve a problem like the Austrians? How do they get them to obey? And I think that's relevant today for lots of reasons. I'm going to hit play. Before I do so, I see Maddie, I see Olivia, I see Lexi, I see
climbed
Jamie.
the tree and scraped her knee. Her dress had got a tear. She wanders on her way to mass and whistles on the stair. And underneath her whimper, she had curd in her hair. I even heard her singing in the abbey. She's always late for chapel, but her penitence is real.
Before we go any further, I think there's a metaphor here for us, the teachers, being the nuns, and you guys being Maria. They're always late for everything except for every meal, right? I mean, I wonder why. Why don't you guys be late for recess, right? Not who you are. It's not. I want to do it. This lady right here is every teacher.
Always late for everything except for every meal. I hate to have to say it, but I very firmly feel Maria's not an asset to the abbey.
This is teachers in meetings, and they're like, they just don't show up to the online class. Arrgh!
That's not because I think.
Right?
Worst thing.
They're lazy. They're this is why it's happening. And it's interesting, you know? I think one of the comments I've heard so far about portfolio reviews yesterday is that they went pretty well. Do you agree that they went pretty well? Were they beneficial? Were they? Okay, you felt like they were. Is there any critique that you have? Any comments you want to make? Any suggestions?
Last two.
None? Okay, well, I want to give you a chance, and you can always, tell me later. But one of the things I noticed is that 5 minutes just wasn't enough. It was a lot of me talking, very little of you talking, and I think that was because I was trying to rush to get to the next person, not be late. I think we should make it 10 minutes, but here's the problem. I have 69 students. Nice. And I need 10 minutes for each of you.
That's a lot.
You do the math, right? We're talking almost a little over 11 hours. Okay? Straight. And I did 8 to 3 yesterday straight, pretty much no breaks, with 5 minutes. It flew by, baby. My solution to that, and you can tell me what you think about it. My solution is that on 8A, or we already have 8A B-Day kids, right? Every other week, we're going to require you to do a portfolio review. 8A kids 1 week, B-Day kids the next. That doubles the amount of time available, right? Because it halves. There's a little multiplication thing going on there, right? We doubled one, halved the other. It's the same problem, right? Just different way of looking at it. So, I think that'll work. Can you show up on a week when you don't have to do a review? Sure, come and get feedback, right? That's helpful for those of you that want to be like, hey, is this okay? Get some actual time, right? Let's do that. What do you think of that plan? Okay, so the one thing I've heard about is that they wish they did it in person, right? Portfolio review would be better in person. And I hear this a lot, right? We're talking about whether we do in person or remote or this hybrid half-ass model or whatever, right? And I agree. In person always better. Here's my logic, okay? It's very simple. Imagine you're a remote learner and you want to do something in person with the kids. What do? You can't, right? Now imagine you're in person and you want to do something online with the kids. What do? Everybody get out Chromebooks, right? Automatically, in-person is better because you have more options, right? By default, you can do whatever you can remotely in person, right? You just can't do it the other way around. So I agree that remote learning is inferior to in-person learning. It is, period. But I don't think the difference is so great, actually. I think the reason it feels so much worse for students and teachers alike is not really, it's not all it appears to be. When it comes to students, I think you guys like it less because you can't see your friends and all this other stuff, and those are valid reasons. Those are very valid reasons. Some of you guys don't have internet, right? Some of you guys have really crappy internet. Some of you guys have really crappy Chromebooks. Other of you guys have really crappy lives at home. Other of you guys have really crappy sleep schedule, all this stuff, right? But I feel like a lot of that can be fixed. Internet is linked to education and has been for a long time. It didn't take 2020 to show that, but apparently it did. They're one and the same. Access to internet is access to education, and in this country, access to education is a right, but access to the internet is not. These are issues, right? Things that we could have resolved over the last 4 months. We tried to by buying hotspots for people, but Lord knows we need a bigger effort than that. We've been needing a bigger effort than that for the last 15 years. Education and internet are linked, and it is not fair for mostly poor rural communities to not have quality internet. That's not fair to you guys. Supreme Court says it is, but it's not. When it comes to the teachers, here's their perspective. They're not showing up to class. I have to be able to know they're there. I have to have their camera on. They got to have a timestamp. I got to be able to see their eyes, and I got to surveil them. Surveillance. That's not what I'm in the business of doing. Compliance. They got to be there. And why do they want that? Not because teachers are evil necessarily.
I don't know.
But because in regular schooling, how does the teacher know you're learning?
Because we're here.
You ever heard that phrase? Eyes on me. Eyes on me. I'll wait for eyes on me. They teach you to do that in teacher school. Isn't that annoying? It's not just annoying, but here's the thing. Olivia Barons wrote a beautiful post in her portfolio recently. Okay? Didn't have the best grammar. It wasn't beautiful because of those things. It was beautiful because she's right. Olivia Barons said, when I was in school, like when she's talking about her history of math, and in part of that she talks about school in general, and she says, it's okay, Emery, I see you. She says, I remember hearing the phrase, eyes on me, right? Turn in your homework, do all this stuff. And in this class, we don't have to do that. We can do whatever we want. She starts out saying in her thing, in this class, we can be on our cell phones, we can go to sleep, we can do whatever we want. And imagine a teacher reading that. This guy's nuts. What do you mean he lets them do this stuff? Right? But the next sentence she writes is this. In other classes, I'm not paying attention because I'm thinking about stuff on my phone. I'm thinking about that Spanish test I have next hour and how I want to study for it. They won't let me do it. And so despite my eyes being on the teacher, despite getting an A in the class, I'm not learning and I'm not really paying attention. But the teacher thinks I am. You see, in-person learning is better for teachers because how do we judge whether you're learning or here and paying attention? Well, your butts are in the seat, your eyes are on me, and you got the A. Remote learning does something that is unforgivable, and the most thing that it does that's unforgivable is that it shows the problems in education that we've had all along, that we can no longer sweep under the rug. Remote learning did not make you not want to show up for class. Remote learning did not make you not learn. Remote learning did not do those things. Remote learning showed that you don't show up for class. And they say, well, it's because they're lazy or they don't want to learn. Maybe. We all are.
That's not good.
But I don't think you're more lazy now that you have remote learning. I just think that we can see that you are, and you don't want to be there. Now, why didn't you want to be there? Well, some of you are lazy, sure, whatever. We all are, right? I'm not going to blame you for that. Some of you guys need to take a nap. Some of you guys have crappy sleep schedule, right? There's all kinds of reasons, and they're valid reasons. The reasons we need to address instead of just sweeping them under the rug and saying, oh, they're lazy, right? That doesn't do anything. Let's be productive here. Let's think about what we can do. One of the reasons why you guys are showing up for class is because you never learned in the first place. And now no one's making you have to have eyes on the teacher. So why would you? You're not learning anyway. Before you did it because you had to. You still weren't learning. The teachers thought you were because eyes were on me and they got the grade and their butts were in the seat. And look, they have an A. And now that that's revealed, it's unforgivable, right? So this is an issue. Hey, Zach. Come on in, set the reminder. So, I don't think remote learning had to be this bad. I think it could be a lot better. And I think it could be pretty close to actually in-person learning. But because we chalked up spring to being, oh, they were lazy, it's because we didn't have grades, it's because all this. Instead of being, you know what, maybe they're not actually learning and they never really worked. Maybe showing a screen to a bunch of kids and demanding that they be there and checking for their eyes isn't the best way to do education both online or in person. Because that's what we were doing in the past. So when they try to get you to go back 5 days a week and get back to normal, remember that the reason they're able to do that is because they showed you that the opposite of normal, remote learning, is a terrible, awful thing. And here's why, because we made sure it was. So how do you solve a problem like Maria? Let's go further. This is the teachers versus you.
I'd like to say a word.
And the teachers are great, by the way. They really are. They're in a bad system.
Makes me laugh. How do you solve a problem like Maria? How do you catch a cloud and pin it down?
Do you see what she's doing here? How do you catch a cloud and pin it down? She's comparing that to how do you solve a problem like Maria. They're the same question, just different way of looking at it. That's what we do in math, right? Same equation, just different way of looking at it. Move stuff around. Like a Rubik's Cube. How do you catch a cloud and pin it down? What's the answer to that?
Go.
You can't, right? Magic. You need something, right? You need a carrot or a stick to hold these kids together. Carrots for the kids that do well, right? Ooh, and now you've got 18 carrots and you're like, why should I work to get the 19th one? I don't even like carrots. The metaphor is the carrots are the grades. You've already got an A. Why should I do more? Why should I learn more? The sticks! We're gonna beat you, right? If you don't learn, I'm gonna smack you. I've been smacked 12 times. What's the difference between smacked 13 times? The kids that are getting smacked know they're gonna get smacked. They don't care. I already got an F. I got an F in every other class. Well, if you don't have a good grade, you won't get to college. I'm not going to college. Not learning anything anyway. What's the point of getting a grade? They're right. Sticks and carrots don't motivate people. Whenever teachers go to these conferences and they say, here's how to motivate your kids, it's full of crap. You cannot motivate someone. And every time you try to with a carrot or stick, all you do is kill the intrinsic motivation that they have inside of them since kindergarten. You guys want to go to school today? Yay! You want to do math? Yay! And then we do math, and we beat them with grades, we give them carrots and sticks, and they learn, you know what, math kind of sucks. Even though that's not really math, it's just conformity and compliance. It kills the motivation you had already. How do you catch cloud and pin it down? You don't. Not because you can't, which is true, but because you shouldn't.
How do you find a word that means Maria?
Them calling you lazy, they don't, all the excuses, right? That's why they don't show up. That's why they don't learn. No grades.
Many things she ought to understand. But how do you
Many things she ought to understand. How do you make them say and listen to all you say?
How do you keep away?
Am I being obvious enough? The beauty of the wave is that it doesn't stay. Here we go. How do you hold a moonbeam in your hand? Why does someone ask a question like that? One of the things I think that's great about the moon, that makes the moonbeam interesting, is the fact that the moon appears every night, and everybody gets to see it, for free. This beautiful, magnificent thing that's bigger than all of us, both literally and metaphorically. And you get to see it, and it casts its light upon you. Why does it do it? Do you deserve it? No, but it does it anyway. And you get it for free, and everybody has access to it. The person who's asking, how do I hold it in my hand? Why do they want to hold it in their hand? They want to own it. They want to bottle it, stick it in a stew, put it on display, an amusement park, sell tickets. How do you hold a moonbeam in your hand? It's not that you can't do it, although you can't. It's that you shouldn't want to. It defeats the purpose. We're missing the goddamn point. When we want to hold you guys in seats and make sure we're able to see your eyes on the television, right? And that you're there and you're doing your work and you're filling out the Google forms, they're missing the point. The reason we want you here is so you learn. And this doesn't help. It makes it worse. Anyway, how do you solve a problem like Maria? I say that all the time because I love referencing this movie. I think it matters in multiple ways. And again, this is a setup for the Nazis coming in to invade Austria, making them compliant. The beginning of the movie is just lighthearted. Oh yeah, how do you solve a problem like Maria? She needs to be a better nun. Or maybe she doesn't. I believe in freedom. But you missed the bigger point. This is a metaphor for the Nazis coming in and taking over. It starts small.
Go to a TED Talk.
Anyway, so what we're going to talk about today is how do you solve a problem like Maria? And the problem that we're going to solve is this one. We might do 2 problems today, guys. We'll have to see. How would you solve a problem like Maria? We're talking about subtraction, baby. I had Mountain Dew on the way to work this morning, so it had time to kick in. All right. Normally I drink it when I get to class. That's the difference. How would you solve it? Play around with your math. Everything is permissible. You do whatever you want. Doesn't mean it's always beneficial. Right? Mika Jacobs was studying for her Spanish class, or Spanish quiz next hour. She asked, could she study during class? You're more than welcome to. If I can't convince you with what I'm talking about to pay attention to me instead of studying Spanish, I'm not very good at my job. Right? 10 minutes into class, she's participating, right? Not because I'm trying to win a power struggle, but because it makes sense. Put that away, get it out of your head. That way you can actually do something good. Until you do, you're not going to be able to do anything in class. You're going to be thinking about it in your head. It'll take way longer to learn it. And memorize that stuff for your next quiz. Go ahead and do it, get it out of the way, and come back when you're ready. How do you solve a problem like Maria? How would you do this? Give me a method.
Oh.
Yeah. Ooh. So talk me through it. Talk me through it. Kobe. Okay, quiet. I gotta be here. What's going on here? This is different. I've never heard this. This is great. Keep going. I love this. Yeah? So you're counting the number of lines in the shape? Okay. I've done something like this in the past. Tell me if this is the same. I do dots. So 4 is 1, 2, 3, 4. Right? And 7 is 1, 2, 3, 4, 5, 6, 7. I map them out, right? And so here's 4 dots, and there's 10 dots here. So I need to take away 3 more. So I've done 4 dots for my 7, right? And I need 3 more dots to finish. There were 10 dots over here. So we're really doing 10 minus 3, which is 7. Is that anything like you were talking about? Not at all. Okay, try again. What else you got for me? Yeah, sure. Go ahead. Go work on it. While you're doing that, get ready to explain it.
Okay, so like you have a line here.
And that's how you do it, because it's 7. Okay. She's counting the number of lines. So 1, 2, 3, 4, 5, 6, 7, 8. Well, I guess you're not counting this, right? Because I added that in. 1, 2, 3, 4, 5, 6. Oh, it's when you pick up your pen. 1, 2, 3, 4, 5, 6, 7. That's the answer. Interesting. I like that. Has nothing to do with subtraction as far as I can tell, but I like it, yeah. These kids are so far out of the box, I don't even know what world they're in. This is amazing. You're just moving that over to a plus sign, and I got 21. I asked them how they would do it, and they're like, I don't agree with your problem. I'll change your problem. I'll make it what I want. Oh, I love that. What if you couldn't? I think that's a more interesting question, right? What if you couldn't? Ooh, 3rd hour. 4th hour? 3rd hour. 4th hour. 4th hour. Woo! Love you. My favorite class. We know each other so well.
Oh, yeah.
How would you solve a problem like Maria? How would you explain this to like a kindergartner to convince them that the answer is 7? We all know the answer is 7. Actually, hold on. Let's do a better one. Let's do this.
How do we know the answer is 7?
Well, it was 7 before. Now it's different. How would you do this? Come on. There's lots of different ways. You've been taught some ways. Come on. How would you do it? We cross and carry, right? We carry our cross, right? Carrying crosses, always a fun thing to do. So, no wonder they don't like math. What do we do now? 11 minus 7. So what you're telling me is that that little 1 stands for 10, right?
Yep.
And then we've got the regular 1 that stands for 1. What does this one stand for? 10. So we're rethinking of the problem as 10 plus 10 plus 1. That's what's really happening here. And then when we subtract 7, Well, which one do you want to subtract 7 from? The 1 or one of the 10s? Okay, so 3, and we get 14. So in other words, 11 minus 7 is 4. How do you know that? Just it.
Yes.
Good guess. It's a great guess. How do you know 11 minus 7 is 4? Okay, give me another reason. Mitchell, go back to your seat, please. 11 minus 7. It's a 6 feet thing, not because you're talking.
4.
How do you know?
11 minus 7.
How do you do it in your head?
10 minus.
Ooh. She's thinking of 11, but just taking that one later, right? We'll deal with that one later. We'll do 10 minus 7 and get 3, and then add 1 onto it and get 4. That's one way. Ooh. Give me another.
7 plus 4.
So you're saying 10 minus 7 is just starting on 7 and going to 10, and you're counting up 1, 2, 3, 4 to get to 10. Or sorry, 11. My bad. Numbers are hard. That's what you're doing. You're counting up. Ooh, I like that. If we can count up, can we count backwards? 11, 10, 9, 8. Wait, what? 11, 10, 9, 8.
You're counting 11.
Oh, yeah, we didn't. From 11. 10, 9, 8, 7. There we go. Okay, good. So it works. It works, right? We wouldn't do 7, 8, 9, 10, right? You skip the number you start on. So starting matters. Starting matters. If I'm on 7 and I'm going to 11, whoops, writing's hard. If I'm on 7 and I'm going to 11, you said you can count up 1, 2, 3, 4 and get there. I'm going to ask a different question, totally different question, unrelated, okay? You ready? What's the distance between 11 and 7?
4.
Oh, wait, they are related, aren't they? How did you figure that out? You subtracted them. What you're telling me is that the distance is subtraction, yeah? Define distance, you subtract. 11 minus 7 is 4. That's the distance between two numbers, 11 and 7. Now, we started on 7 and went to 11. We went this direction, yeah? To the right. Notice that we started on 7 and went to 11, but we start with 11 here. Kind of reverse, isn't it? What this is asking is, if I'm on 7 and I go to 11, how far, the distance, do I travel? Start here. The second number is the one you start on, right? Because what happens if I go this direction? What if I go backwards? If I'm going this way, right? It's negative. I went to the left 4. So negative signs and subtraction are similar, but not the same. Negative sign just means direction, which way you're going, right? I'm heading 4 to the right. If I'm starting on 7 and going to 11. If I'm starting on 11 and going to 7, I would write it like this. Remember, you start on the second number and go towards the other. Minus 4. Now, in real life, does direction matter for distance? If I'm here and going to Fulton, is that a different distance than if I was in Fulton going to here? No, it's the same. The only reason it would matter is if your grandparents, back in my day, we went to school in the snow, uphill both ways, right? Then direction matters, apparently. Uphill both ways. So, normally when we talk about distance, we don't worry about the negative. We just assume all distance is positive. We do absolute value. You guys remember that? From algebra, the two little lines, right? The absolute value of -7 is 7.
Oh.
Still no.
Okay, good. Well, the reason we have that is because it's convenient to think of distance as positive. Because imagine if I wanted to go to 12 after traveling to 11.
+1.
I went -4 distance, right? Because who cares what sign it is? And then I went 1 further. I traveled a total of -3 distance. Wait, I traveled to the left? -3? You see how it's better to think of it as positive? Because you can add positive and subtract positive in any order you want. Right? It's easier to think of it as positive. So that's why we always think that distance is positive. Unless we care about direction, right? Maybe I went to the left 3 and then went to the right 5. Well, in general, I just went to the right 2, right? So subtraction is distance. Let's talk about algebra last year a little bit before we get back to the main problem. You guys remember this?
Probably not.
I was talking about this with some algebra kids in the morning. They said an algebra 2 quiz coming up. They're like, oh yeah, 2 points, we have to find the slope.
No.
You remember this? No? You hate it? You love it? You hate it? What would you rate it? So, what does M stand for? Isn't that crazy? The slope. Now, why do they give M slope? Why do they give slope M?
Just because they're not very small.
Well, S looks like a 5, and also the French came up with it, and the French word for slope starts with M. The more you know. Today I learned. So, this is slope. They call it slope formula. Okay, great. Awesome. It's y2 minus y1 over x2 minus x1. I have that right. You have no idea what it means. Let's talk about slope. What is slope? What's the idea? Like, what does slope mean? Ooh, you're thinking diagonal. Good, good, good. What else?
Going up.
Going up. But we can also do what?
Going down.
Going over and down, and right? It's steepness. Like a hill, slope, right? Like when you go on sled. A really steep hill goes up a lot, but not over a lot. It's like this, right? Like that's a really steep hill. That's a wall, sir. So this is a Wendy's, right? So this is a vertical slope, really steep, right? Well, what if it goes over more? Then it's not so steep, right? So it has to do with how much we go up vertically, right? And how much we go left and right horizontally. It's a relationship there. Really horizontal, not very steep. Really vertical, really steep. Somewhere in the middle, right, there's a relationship. No, you're not even math class, Gina. Eyes on me. So, slope has to do with vertical and horizontal.
It also has negative.
And we say how far, right? How far we go up, how far we go over. When I say how far, what do you think of? Other than Moana or Hercules? I will go the distance. You know a Hercules movie?
Nope.
Do I find my hero waiting white where I belong? Bum, 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 ba-da-dum, bum, right? It's a brilliant movie. They're talking about Greek gods and they use gospel music for the soundtrack. Genius. Anyway, right?
Boy.
A movie about gods, let's use God music, right? Gee, Alan Menken, what a genius. So slope has to do with how far we go, distance, right? So when we talk about how far it goes vertically and how far it goes horizontally, I'll abbreviate that. We're talking about the distance, right? Right. There's a relationship there. Now you remember from my class, relationship is division, right? Ratio, but we're not going to talk about that yet. So, you said earlier, distance is what? It's the same thing as what? How do we find distance? Subtraction. Distance is subtraction. Wait, hold on. I've got a question. Which variable, x or y, deals with the vertical?
Y.
I ask the questions, which variable, the x or the y, deals with the vertical? I ask the question. All right, so it's the y variable that deals with the vertical. So the x deals with horizontal, left or right. Yeah? You with me? Okay, awesome. So, wait, what? Oh, what? What do you see there?
Why?
What do you see
It's
there?
a minus.
Subtraction. What is subtraction?
Why?
So we're talking about distance. Very good, Gina. We're talking about distance. What kind of distance? Wait, we're talking about y values. Which variable deals with the vertical?
Why?
I asked the question.
Just
This is distance because it's subtraction, yeah?
that'll be good.
And it's y, so it's vertical. It's vertical distance. What? It's vertical distance. It's vertical distance. That's what that means. How far it goes up, right? How steep it is vertically.
Yeah.
What does this stand for then?
How steep it is.
Come on, cowards. There you
How
go.
steep.
Horizontal distance.
X.
That's what this means, and that makes sense because what is slope but the what over the what?
Y over the X.
The y over the x, the what over the what? Come on, they make you say it all the time. The blank over the blank. This is what normal class is like, right? We wait for you to say the right answer. We say, oh, very close. Oh, very good. You got it right. Now we can move on, right? This is just an element of my class, not the whole class, I promise. The blank over the blank. What do they make you say? It's the
Distance?
This is education. Can you? Isn't it great? I'm getting hints.
Run
The
over
rise over the run. Rise. How far we go? Run. How far we go? Vertical distance over horizontal. Slope is rise over run. It's vertical distance over horizontal distance. Duh. Sir, I think what you mean is M equals y2 minus y1. What does that mean? Nothing. I'm never gonna remember that. It's vertical distance over horizontal distance. How do they come up with this? Well, they just invented it. It wasn't me. I have no idea. No, how did they come up with it? They did something that we don't have time to ever do in class. We never do this in education. How did they come up with it? We never do it in education. How did they come up with this? They thought about it.
It's really smart.
It's rise over run. Vertical distance over horizontal distance. How would it represent that? The distance vertically, distance horizontally. Subtraction is distance. If you want to write about this, do it soon. Don't wait a couple days. Go back and watch the video. Earlier classes had a little bit of a better spiel. Second hour usually is the sweet spot. I go check out there. Spend time thinking, not just writing.
Only 8%.
I love you all.
You know, I have to
Get me on the TikTok.
all the time. It's gonna... You should put
You should be on TikTok. You should run for president.
I charge my phone. Shut up, dude.
Hey, you should go to a TED Talk and talk about
Who would vote for? I'm some crazy. I'm just some dude. Okay, I don't even have a full math degree. All right, so.
You should run for president.
Yeah, okay. The only problem with that is I might win.
You over Biden, not gonna lie.
Oh, me and you both. All right, so anyway, that's subtraction, distance. That's one way to think about it. We're gonna play around with it more tomorrow. Make sure you're there for class if you want to learn more about subtraction, okay? And if you don't show up.
If
See
you
you later. Bye. Love you.
you shouldn't be fake.
Take care. What happens in math class stays in math class. Snitches get stitches. I forgot to change the title of this one. It's the moment. Welcome. Learn about subtraction today. What is subtraction? Uh-oh. Learn about subtraction today. What is subtraction? What is subtraction? 7 minus 5. Think about it. I'm underlining. What is subtraction? And remind you of your work cut out for these guys. They learned nothing from me last year. I just don't have to.
McAnally, don't do it.
Have a good one, guys. Oh, it's study hall? Are you kidding me? I was on a roll. Okay.